All right, guys, different kind of read aloud today. We're actually going to be working on some of our science. So we're looking today at what kinds of circuits are there. In your science book, this is page F82 and F83. So go ahead and open up and follow along, or if you don't have your book with you, make sure to check out the ebook that I have posted on our Google Classroom page. So we've been talking about electrical circuits, talking about current electricity. There are different kinds of electrical circuits, and that's what these two pages look at. So looking at what kinds of circuits are there on page F82 and F83. Many circuits have two or more objects in the circuit. How can these paths be set up? One type of circuit has the two objects connected in a single path. This arrangement is called a series circuit. In a series circuit, electricity can flow in only one way. Now pause for a moment and think about where you've heard the word series before. Maybe a book series where you have, maybe let's take for example the Harry Potter series or Little House on the Prairie series. You have one set of books, there's all different books in the series, but they all have kind of the same characters or the same setting. They all kind of focus on some common things, some things that are the same. The World Series in baseball takes the same two teams and they play 7 games to see who would win the championship. Same thing with a movie series or a television series. There are different the same characters in different situations. So we have something that's the same. And that's kind of what we can think of with a series circuit. Like it said there, they're on the same path or a single path. Okay? It says the diagrams and the arrows below show how current flows. The arrows in the diagram below show how the current flows. So if you take a look down there at the diagram that says series on page F82, or hopefully I'm going to be trying to project that behind me as well here. So with the series circuit, we have both bulbs side by side, and then we have the electricity flowing in one direction going through both of those light bulbs. It goes on at the top of the next column to say that when both bulbs are in place in a series circuit, it is a closed circuit. We know that a closed circuit, when a circuit is closed, electricity flows. Good job. Okay. When one bulb is removed, an open circuit is created. So if I take that series circuit and then I take one of those light bulbs out, now I have the open circuit there. So the electricity can't flow at all. Once that light bulb is removed, that circuit becomes an open circuit and the electricity doesn't flow. Okay. The remaining bulb does not light. I skipped a sentence there maybe. When one bulb is removed, an open circuit is created. In an open circuit, current can't complete its path. The remaining bulb does not light without current flowing through it. A series circuit does not work when a part is removed. So let's take a closer look here at an actual example of a series circuit. Now, I like to use 3 light bulbs for this demonstration because in your book, the diagram shows just 2 light bulbs. And I wanted to point out that it doesn't have to just be 2. You can have any number of things lined up in a series circuit when they're all connected. So hopefully you can see here, I turned off the lights, so hopefully you can see the strength of these light bulbs. It's actually pretty dim with those 3 light bulbs at the same time. That may or may not be visible to you on the screen, but hopefully in a minute you can see the difference. So there's a little table there at the bottom of F82, and under series it says in the connection the bulbs are on the same circuit. In your book it says both bulbs, here it's 3 bulbs. Removing one bulb means both bulbs go off. So if I take one of these light bulbs, doesn't matter which one, and I unscrew the bulb, the other ones go off. Okay? And I started out with this one, but it doesn't matter if I go to this side, it's still going to turn all the bulbs off by removing one. And the reason for that, what if I do the middle? By now your hypothesis is probably correct that again, all those bulbs are going to go off as soon as one bulb is removed, okay, from the connection. So the reason for that is that the electrical current goes from my battery through the first bulb and then into the next wire to get to the next bulb, through that bulb and into this wire to get to this bulb, and then back to the battery. So it's that electrical circuit passing through each one of those items. Each item is on the circuit, so that's what's causing it to go out. If I take a bulb out, it opens the circuit. The last thing says that the brightness in a series circuit is dim. So we're sharing that same electricity among all three of those light bulbs. It's passing through one to get to the next, so it results in a dimmer connection. So that's the series circuit. And we usually don't want to wire things up in our home like that. We'll talk about that a little more here later on the pages. So that's the series circuit. Now let's take a look at a parallel circuit. This is the last paragraph on page F82, starts with another type, if you're following along with me. It says another type of circuit has the two objects connected in a parallel circuit. A parallel circuit connects each object to the cell separately. Now I kind of remember that because parallel and separately both have a P series and separately both start with S, so that gets a little confusing. But I think of series, same, parallel, separately is the only one that has the P in it. So that's kind of how I keep them apart. It's not perfect, but kind of works. There are two paths through which current can flow. Maybe you're familiar with the term parallel from math class. We talk about parallel lines, okay? Parallel lines are lines that will never ever intersect. A line in geometric terms is a straight path of points that goes on forever in two directions. So even if these lines keep going forever, they're never going to cross over one another. So that's parallel. Parallel circuit has the two bulbs on separate paths. So in this case, it goes on in the next paragraph on page F83. When one bulb is removed from a parallel circuit, the other bulb is still part of a complete circuit. That is why it remains lit. A parallel circuit still works when a part is removed because there is still a complete circuit. The chart on F82 that we just looked at a moment ago compares series and parallel circuits that contain two bulbs. Now, since we looked at a series circuit, let's go ahead and take a look at a parallel circuit. Okay, so here we have our parallel circuit, and what I hope stands out, I hope you can see this from home on the video. I hope you can see how much brighter the light bulbs are. Now, I didn't change light bulbs. I didn't change batteries. This is the same battery, same light bulbs. When you're doing a science experiment, you want to make sure as many things as possible are the same. Now, I did switch wires just for convenience sake. I have this one already kind of set up. But in theory, I should actually use the same wires, same light bulbs, same battery, same everything. The only thing that should be different is the way that I have everything set up. So now I have this set up as a parallel circuit. So I've got more wires actually, and I know that's hard to see because I have two wires going to each battery or light bulb connector. And so what you see here is that if I take this light bulb out this time, the other two are going to stay lit. So we've got a brighter connection, and then if I remove a bulb, the other bulb is going to remain lit. Okay. And then of course if I remove the third one, you probably now know what to expect. There we go. So the parallel circuit, it's a little more complicated to set up, but it also has some pretty strong advantages, like the fact that I get brighter lights in this case, or more electricity to each device if I were wiring up different devices other than light bulbs. So that's what I'm looking at here with the parallel circuit. So that's the difference. I'm going to try to have both of these side by side here just so you can see. So let's take a look and see if I can make this happen. I'll be popping out of the scene for a minute here. We'll see if we can look at these side by side and compare. Okay. Okay, so what you see here is the series circuit on the right, parallel circuit is on the left, and you can kind of see there side by side then the difference in brightness between those two different types of setups. So hopefully that gives you a clearer understanding of kind of what the differences are there. All right, so our last paragraph here at the second column on F83, to wrap this up with the book reading, says electrical devices in homes and other places are connected in parallel circuits. If they were series circuits, all the lights and appliances would come on every time you turned the switch. So imagine that. If you had your house set up in a series circuit and you wanted to watch TV, you'd have to make sure the lights were on all through the house. If you wanted to play your video game system, you'd have to make sure that the toaster was plugged in and turned on. So everything would kind of have to work together. So series circuits really aren't practical for that purpose within a house. Likewise, everything would turn off if one bulb burned out. So you can imagine if you wanted to turn off the lights, your refrigerator's turning off. It's not going to work. So you need to be careful of that. Okay? So that's why most homes use parallel circuits. It says circuits in homes and other places are controlled by switches, which we already know. Switches are used to open or close a circuit. Okay, so to wrap this concept up, I want to actually take a look at the chili pepper lights here above me, and I want to show you something with these. So I'm not really going to say anything or explain anything. I just want you to think about what you're observing. So I'm going to hop up here, and I'm just going to start out. Let's start out way down on this end. Make sure you can see that. Whoa. Okay. And we'll take one of these. Now the chili pepper lights are actually just kind of a little plastic rubbery covering. So that I can take that off, and then underneath are just like ordinary Christmas style lights. So I'm going to pull one of those light bulbs out, okay? And then what you'll notice here, and actually you're not seeing all of the lights, but if I rotate the camera there, what you'll notice is that half the lights are out, okay? So let me put that bulb back in. Go, and they're back on. It's going back on. There we go. Okay. So a lot of times people will say take out the middle one, which is a little tricky because it actually isn't the middle one, but there, right there we have that bulb. And again, this whole side's out. Okay. Let's put that one back in and go one beside it. I go here. Now the other side's out. Finally, sometimes people want to see what happens if I go all the way to the end. Let's go down here all the way to the end. And just to show you here, that's once again just half the lights are out, the other half are on. Okay. So if we were together, this is where I would ask you to pass out a Collins writing paper, and I'd ask you what you think. Are these chili pepper lights a series circuit or a parallel circuit, and how do you know? So think about that, and actually maybe type a comment, or maybe I'll attach a Collins writing paper to this, because I'd love to know your thoughts before I explain it. And actually, I'm going to stop the video here. I'm not going to explain it right now, but I will answer when we're back in person together, or after I get everybody to submit, I will post a comment that kind of explains what's actually going on here with these chili pepper lights. So series circuit, parallel circuit, how do you know? Give yourself a minute or two to answer that. It shouldn't be a long, extensive writing, and don't Google it, okay? So that's the end of this lesson. Hope you've learned a few things about series and parallel circuits. Some important things to remember are that there are two different kinds of circuits. They are called series circuits and parallel circuits. That with a series circuit, everything is connected on the same path, and with a parallel circuit, everything is on its own separate path. Okay? Thanks for tuning in. Hope you enjoyed that, and I will see you next time.